Hello, welcome back to another insightful PVsyst tutorial on my channel. On this channel, I share practical PVsyst tutorials, solar design tips, and real-world simulations to help you become a better solar designer. If you've been trying to design a dome-shaped solar PV system in PVsyst but haven't been successful, then this tutorial is for you. In this tutorial, I will show you how to design a dome-shaped solar PV system using the PVsyst software. We will cover the entire process from system design to creating the dome geometry in the PVsyst 3D environment. We will also cover how to activate panel bifaciality when designing dome-shaped PV system. If you are ready to learn and improve the quality of your solar designs, then let's get started. Before we begin, don't forget to like the video, subscribe to the channel, and turn on notifications so you never miss future PVsyst tutorials and solar design tips. In this tutorial, you will learn how to enable bifacial PV model modeling when designing a dome-shaped solar PV system in PVsyst. By default, PVsyst does not allow bifaciality to be activated when a project is modeled using the dome-shaped orientation. This is because the dome-shaped orientation is a simplified array model intended for fast energy simulations and does not perform the detailed rear side irradiance calculations required for bifacial models. To overcome this limitation, we will model the domed array using two fixed tilt orientations, one representing the east-facing models and the other representing the west-facing models. This approach enables PVsyst to calculate the rear side irradiance and allows bifaciality to be activated while accurately representing the geometry of a dome-shaped solar PV system. So, for us to start designing our solar project, to open a new project in PVsyst. First, we will give our project a name and select the site location of our project. With the site location, we are going to use the longitude and latitude geographical coordination of the solar site. After you have entered the longitude and latitude coordinates of the solar site, you go to Get from Coordinates to get the name of the location from the coordinates you have entered. Then you click on Import to import the weather data of the site. You click on OK. Next, you save your project. The next thing we are going to do is to select or define the orientation of these PV panels. So you go to Orientation. For this solar project, we are going to use a dome-shaped solar PV system. So you are going to select the domes instead of the fixed tilted plane. We are going to give it a tilt angle of 10 degrees. Then you click on OK. Next, we have to specify the system. You click on System, and this interface will appear. Then you have to let the software know the capacity of solar system you are going to install. So for this tutorial, we are going to design a 100 kilowatt solar PV system. Then you select your panels and the inverter you are going to use for the project. For this project, we are going to use 600 watts Longi solar panel and a 100 kilowatt Huawei inverter. We are going to have 17 PV modules installed in series and 10 strings. We are going to, since we are designing for a dome-shaped solar system, we are going to activate the second orientation. And we will share the orientation between the two orientations that we have. So each orientation will have 5 strings. After that, we will go to near shading. This is where we are going to draw the 3D system of our project. For us to start designing our dome-shaped solar PV system, we will go to Create. Then we will click on Array of Domes. Over here, we have to specify the parameters of our domed solar PV system. We are going to have 5 number of shades for our 90 degrees. So for this project, we are going to have 5 number of shades, and then the pitch for the PV panels or the sub-array is 6 meters. We are going to have 17 PV models in series and 1 string in a sub-array. After you've specified for the parameters, you click on OK. You click on the move to position your PV array well. Then you calculate your shading factor table. Then you click on OK. Now we have to go back to system and activate the bifaciality of the PV panel. For this project, you realize that PVsyst is saying the orientation that we have chosen for our PV system is not compatible with the bifacial 2D model. So we are going to try another alternative that will help us enable the bifaciality for our dome-shaped solar system. Now, since we are going to design a dome-shaped solar system, we have to define 2 fixed tilt planes with different orientation so that we will get our dome-shaped solar system installed. So we would have to add another fixed orientation. and give it a plane tilt of 10 degrees. And then we will give the azimuth 180. After we have specified the orientation, you go to System. First, we would have to give the total capacity of PV system we are installing, which is 100 kilowatts. Then you select your PV modules and inverter. You have to activate the second orientation and share the orientation between the two orientations we are having. We are going to have 17 PV modules installed in series and 10 number of strings. Then go back to orientation distribution. Then you click on OK. So we are done with the system. We will move back to near shading to design our 3D system. So for this scenario, since we are designing for a dome shaped and we have defined two fixed orientation, for this second scenario, we are going to define two different fixed orientation and arrange it so that we'll get our dome shaped solar PV system. So you go to create. So for this scenario, instead of choosing the array of domes, we are going to choose array of tables. Then you specify the parameters for this array. So for this array, we are going to have 5 shades or sub-arrays. We are going to have 6 meters as our pitch. We are going to have 17 panels connected in series. And then we are going to have 1 string in a sub-array. And we will choose the portrait orientation. Then after you are done with it, you go to close object. Okay, so we have specified for the first array or the first orientation. Now you have to create the second fixed orientation. You select your array of tables, then you specify the arrays parameters. You have 5, the pitch 6. You select the portrait orientation. Then we have 17 PV models connected in series, and we have 1 string in a sub-array. Okay, so now we have the two orientations. We have to position them well to get our dome-shaped solar PV system. So you can see that we are having the dome-shaped solar PV system using the two different orientation. From here, you can specify the partition. We have 17 PV models, and then we have 17 and then 1 string. Then you go to apply. You can also change the color of your PV models. You scroll down, then you select color. You can select whatever color you want. Then you click on OK. Then we do same for the other orientation as well. You double click to get to the properties of the arrays. Then you go to partition. You define partition. Then you go to apply and change the color for the sub array as well. Then you click on OK. So you can see that we have defined the partition and then we have also changed the color as well. So this is how our solar installation looks like. Okay, then you click on close scene. Then you calculate your shading factor table. Now, let's go back to system to activate our bifaciality. So you click on system, then you click on bifacial system. Then you come to use unlimited orientation. Okay. So now we have to define our albedo, the ground albedo. So for this project, we are going to use the albedo factor for grass. You click on the question mark to get the properties of the albedo information. So for fresh grass, we have albedo factor to be 0.26. So we are going to use that for our albedo. Then you click on OK. So this is how you enable or you activate the bifaciality of PV models when we are using PVsyst to design your dome-shaped solar PV system. So from here, you can run your simulation and have a look at your report. So this is the end of our tutorial for today. Thank you for watching.